Hello, welcome to some more video notes. Today we'll be going through part 3 of our Extinction on Mammoths section. Today we'll be looking at what we call roller coaster, and that's coming from this idea that if you look at the overall trends for changes on the Earth's temperature of the Earth over a long period of time, it kind of looks like a crazy roller coaster. It looks like it would be a lot of fun to ride. So let's jump in and do some quick notes just on page 5 in your note packet. All right, so if you remember, we have our reporter. She's trying to investigate what caused the mammoths to go extinct. And so after doing a good amount of investigation in the last few classes, she's determined that it's probably more likely that it was their extinction was caused by climate change, that at the end of an ice age, there was a rapid increasing in global temperatures, which might have affected the food supply, taking away the grasslands that the mammoths would have been feeding on. So because of that limited food supply, and then the stress that that would have caused on the populations, and then also the fact that there were hunters, human hunting groups that would have been picking off some of the adults and maybe some of the weaker ones, eventually the population of the species went extinct just because of this dramatic change to their climate. And so now we're going to get into this idea of, well, how do we know that such changes on the surface of the Earth have happened? Like, how can we have evidence that we've gone through rapid periods of heating or cooling and that the Earth's temperature could change so quickly and so dramatically that something like a woolly mammoth, which was adapted very well for living in colder environments, would not be able to deal with the temperature changes? All right, so here, looking at her, getting into this idea, she now wants to look at what scientists, the information that scientists have collected, looking at how the Earth has potentially changed over millions of years by analyzing ancient sediments, right? Ancient layers of ice, for example, which we'll be getting into in another topic. And so we take that data and we graph it all out. It looks like this. It looks like that crazy roller coaster that I was talking about, right? We see going back versus today, right, on this side of the graph versus the very far left side of it, 500 million years ago, we see that there are some dramatic temperature changes that have occurred through that time period. About 500 million years ago, the Earth was a lot warmer than it was today, right? It was maybe about +6 degrees Celsius compared to the average temperature. And then about 5.5 million years, there was an ice age. Or sorry, not 4.5 million years, there was about an ice age where it was dramatically cooler, maybe only about 2 degrees warmer than it is now. And so that is a pretty dramatic change. You might think these numbers are quite small, but a difference between 6 degrees and 4 degrees for the entire Earth is going to have a huge influence on, which areas of the Earth are going to be covered by ice, which areas of the Earth are going to have grasslands, which ones are going to have forests, which ones are going to have deserts, all right? And then as we continue on through time, getting into 4 million years ago, the temperature comes back up again, right? Maybe around 5 degrees, +5 degrees Celsius. And then from 3.5 million years to that point, all the way down to 3 million years ago, there was a really quick decline. Well, you might not think it's quick, but over millions of years, but it is. There's a quick decline in temperature, even getting down to less or -2 degrees Celsius. So it's actually dropped to a much colder period than it would be at today's temperature. And here we would have had a really long ice age. That's what this bar section at the bottom, this blue square, is to represent that period of the ice age. And then towards the end of the ice age, we have a dramatic spike. Again, suddenly the temperatures are increasing very, very, very quickly, going from -2 all the way up to somewhere between +5 and +4 degrees Celsius, right? So over a very short amount of time, there was a rapid heating on the surface of the Earth. And then we also see in the last 200 million years, there's been a lot of crazy variety of heating and cooling. And then just leading up until more modern day, we don't say today as in like, oh, it's 2020 or something like that. We're talking about today as in maybe like the last few thousand years, maybe like 10,000 years or so. So there was a brief ice age, right? And that's the one that we're talking about, where the mammoths probably went extinct at. And then since that point, the temperature started to increase. And if we were to go further on, we would actually see that it is still increasing today. And so looking at all this data, we're just going to practice analyzing some of it by going through a series of questions that you have on page 5. Okay, so looking at this graph, we see that it tells a story. It tells kind of like what's been happening on the surface of the Earth when there was heating, when there was cooling, when there was probably going to be a lot of really great dramatic differences in environment versus when it might be in an ice age and there would be a lot of ice and snow covering most of the land. And so there would be a lot less diversity. There'd be a lot less unique differences between species and the environments themselves. All right, and so we've got some questions that we want you to go through just to kind of think about how this data tells that story. And so this first one, question 1, describe how the Earth's temperature changed in the past. I'll start you off. Let's say at 500 million years ago, the Earth's average temperature was about 6 degrees warmer than we have today. All right, so then leading into that, right? So you can pause this video and just kind of summarize what you think we should be putting down, right? And so you paused it and you tried it out, right, before I show you what we have here. So then we can start going, going through the fluctuations that we see. So it could have dropped to +2 degrees around 430 million years ago. Then it rose again to maybe about 5.5 degrees at 350 million years ago. And so the temperature rose and dropped repeatedly over millions of years. And the word, the vocabulary word we want you guys to get used to, is this idea of fluctuated. So it means it went up and down kind of randomly, all right? And so temperatures fluctuate a lot going from year to year. And if we look at even from millions of years to millions of years, they do fluctuate. They change consistently, going up and down. They are never exactly the same for very long. All right, then moving into the next question, we see question 2, right, just below that. It says, what usually happens when the temperature dropped? And so again, looking at our data, we see these blue sections. And what are those sections supposed to represent? Right, you added this down, right? So that represents an ice age. And so during the periods where the temperatures dropped very, very low, or the lowest points possible, is where we would be seeing periods of ice ages, right? So here the temperature only getting down to a little bit lower than +2. That ice age wasn't particularly long. It was a very mild ice age. But here, when it got all the way down to -2 degrees Celsius as an average, we had a particularly large ice age. And then here as well, maybe got down to maybe 0.5 degrees Celsius, or maybe near 0.1 or near 1 degree Celsius, or -1 degree Celsius. We had a longer ice age than compared to the first one. And so that's what that is there to represent. Okay, so you got all this information down? Okay, good. So then other things we have of notation here is if we look at the ancient history by looking at the fossils. And so what we can do is we dig into the earth. We find sections of the earth buried deep underground that represent this time period, right? When they used to be the surface of the earth. And so we look at the number of fossils that we find in that area and that time period. And so if we're seeing a bunch of fossils, right, a bunch of diversity, a bunch of different types of species, different evidence of life existing at that time period, well, then we know that there was a lot of life there. And then we start moving to a different layer. We might go deeper. We might be a little bit closer to the surface of the earth so that we're getting closer to our own time period. But if suddenly there's a lot less fossils, right, significantly less fossils present, that means that the number of living things that were in that area dropped very suddenly for some reason. And so when we look at that, we look at the history of what we call these extinction events, when suddenly we had a lot of different living things on the surface of the earth. And then at some point, suddenly something happened or some changes occurred, and then there were a lot less living things on the surface of the earth. And so the amounts of living things on earth also fluctuates. And so we can track these mass extinctions, right? And so if you look at the data that you have on page 2, right, or sorry, page 5, we also see that here we've added it to our graph in our PPT. The mass extinction events seemed to occur during periods of rapid change. Here we had a sudden decrease in temperature, and when we get to our very lowest point in temperature, we're hitting our ice age, we have a mass extinction, right? We have a sudden increase in temperature. Again, temperature is getting really, really high very quickly. We have a mass extinction. Temperatures drop again and then rise again, and again, another mass extinction. And then here, over all these periods of fluctuations, triggers again another mass extinction. And so these mass extinctions. Now, when we say mass extinction, we don't necessarily mean that a few things went extinct. We mean, thousands and tens of thousands of species seem to be disappearing from the surface of the earth, right? So even though the mammoths went extinct maybe about 10,000 years ago, maybe 15 to 10,000 years ago, that doesn't mean that they were part of a mass extinction. Their extinction was unfortunately maybe just related mostly to them. It's not necessarily means that a bunch of species, thousands of species, were all going extinct at the same time. So even though various types of species go extinct at different times in Earth's history, a mass extinction is a very special term. It means that a lot of things, right, thousands of things are all going extinct at the same time or around the same time period. That's what triggers a mass extinction event. Okay, so in your notes, you should add this in, right? So you can find the data on page 5. You can say mass extinction event number 1. It was supposed to happen about 440 million years ago, right? So you can have it around here at this point. All right, so you can use the data to put it in your notes yourself, or you can just look at this image here and try to replicate what you're seeing on the PPT. Okay, so do we get part 3 done? Right, you can pause it if you're not done yet. Okay, good. All right, moving on, we have one more thing we're going to talk about here, is then connecting all this stuff together. Do we think that there's a link between climate change and these mass extinction events? Do we think climate change could cause things to go extinct, cause species to go extinct? Right, this is a key part of trying to find our evidence for why mammoths maybe went extinct. So we want to look at, is there evidence in Earth's history that shows that climate change can actually lead to the extinction of species? So what I want you to do is pause this, right? Put down your ideas. Okay, you did that. Okay, good. So maybe you wrote something like this. Yeah, you could describe this pattern that when temperatures hit very high points or very low points during a rapid change. So remember, the steepness of the lines show that it's a very quick change to go from here to here, right? Over less than 50 million years, or go from here to here over another like 50 million years. That's a very quick change. Right? 50 million years might seem like a long time, but, and we think about that in the history of Earth, that's a very, very short time. So that is a very quick change. And so when we see rapid changes between high and low temperatures, we see that a mass extinction does occur. So if climates do change too quickly, right, and it's a really large change, so a fast, large change in terms of temperature and in terms of the rate that it occurs, that means a species can go extinct. Okay? So we've got some evidence now to support this idea that possibly that it was climate change that was the big factor for the extinction of our mammoths. So as we continue on with this unit, we're going to be looking at more sources of data that scientists use to try to determine what has happened in the history of the Earth, right? How did climates change? How did temperatures change? And we're going to talk about the types of graphs that get produced when we look at this data and the trends that this data is showing us about how things have changed on Earth, and does that help indicate what maybe happened to our mammoths. Okay, so finish your notes, and if you have any questions, please let me know.